schedule. So today we're going to be talking about solving compound inequalities. And so compound inequalities, there are two words you need to remember. And is the first word. Does anybody know the other word?
Intersection, I'm guessing.
And there's another one.
Intersection.
No. And.
Equality. Inequality.
What's another word that goes with and?
Or.
Or. Good. So those are the two key words today, and, or. Now a little bit about and. Whenever we use the word and, it means the intersection. Because in order for something to be true when it uses the word and, both things need to be true. So for example, if I said you are wearing blue jeans and a black sweatshirt, if I use the word and, it means in order for the statement to be true, both things have to be true. Example, if you look at Kylie, is she wearing jeans and a black sweatshirt? No. Is Aaron? Yeah. Okay, so when you use the word and, both things have to be true. So we're going to graph all these. And so in order to graph these, when we use and, we look for what's in both. So I'm going to start with the first one here. On the first number line, I'm going to graph x is greater than or equal to 1. Very first thing, whenever we graph, we always have to start with 0. So I'm just going to go ahead just for kicks and keep putting 0 down on both. Now I'm going to put 1. Okay, so I'm going to start at 1. If x is greater than or equal to 1, I have a, what circle?
Full circle.
Closed. In which way am I going to shade?
To the right.
To the right. To the right. To the left. To the left. Okay, so anyway, the next one, I'm going to graph x is less than 5. So here I'm going to have to add 2, 3, 4, 5. So here's 5. If x is less than 5, what are you going to do?
Open circle.
Open circle on,
5.
shade which way?
Left.
To the left. So now, in this very last statement, what I'm going to do is I am going to graph x is greater than or equal to 1 and x is less than 5. So how we graph using and, it means it has to be shaded both. So I'm looking the places where I see both light pink and light blue. So do I see light pink and light blue at this left arrow? No, I just see pink, right? There's no light blue up here. So as I move along, at 0, do I see light pink and light blue?
No.
No, I see pink, no blue. At 1,
Yes,
I see that this is where I start with both colors. Okay? So as I move to 2, do I see both colors?
Yes.
Yes.
What about 3?
Yes.
4?
Yes.
What about 5?
Yes.
No. What happens at
Oh,
5?
because 5 is.
5, this is no pink right here. At 5, that means it goes up until 5. So actually at 5, I would have an open circle. What about at 6?
No.
No, because it just has blue. 7,
No.
blue.
No.
So it basically stops at 5 and starts at 1. So that is how you would graph the intersection. Intersection means it has to be shaded both. Now there's another way to write an intersection. Okay. The first way we just looked at, this one right here. Okay. The second way to write an intersection is to use this. So whenever you see something written with inequalities that way, it means the intersection. Some of you might pick up on this real easy. Okay. At 1, notice you see a less than or equal to. That means you start at 1. The less than or equal to means you shade it. Okay. Over here, 5 means you stop at 5. You don't shade it because there is no equal to here. Since it's written this way, you will shade in between.
You pretty much told
So basically, this gives you your boundaries. The 1 and 5 gives you your boundaries. You're going to shade in between. Remember, we're looking for equal to signs. Now, if I would have had this, what can you tell me?
It'd be a
Shade
it'd be a
5.
The
full
5 would have been shaded. If I would have had this, what can you tell me?
No.
The 1 would have been open. Okay? So that's another way you can graph. Both of these are intersection graphs. All right. So let's go ahead and look at this. Solve the inequality, then graph the solution set. So if you notice, this is like the first one or the second one we just looked at? The second. Now, some people will break this up. They'll say, oh, this means x minus 3 is greater than or equal to negative 2, and x minus 3 is less than 4. Okay. I don't like to do it that way because I think that's more work. If I look here in the middle, I want to get the x all by itself. So to get the x all by itself, what am I going to do? Add 3. Now this is the thing. Normally with an equation you add 3 twice because you add it on one side and then on the other. With an inequality here, I'm going to have to add it 3 times because I'm going to have to add it here. I've already added it in the middle, and then I'm going to have to add it here. So notice you have to add it on all parts. So here on the left side, what are you left with? 1.
Less than or equal to
What's in the middle? X. Now notice because our 3's here have canceled. Less than 7. So what that does is give you the boundary points. Where are the boundary points going to be? 1 and 7. Okay. Now somebody from that group, tell me where I'm going to start, or start with something. What am I going to do? Closed circle on 1. Somebody from that group, tell me what I'm going to have.
Open circle at 7.
Open circle on 7. This group, tell me what I do next. Shade in between. There you go. That's it. That's all you do. Okay, pretty straightforward. Okay, let's look at this one. Okay, so what are you going to do? Add 3. So I'm going to add 3 here and here. So now I get y is greater than or equal to what?
-4.
Negative 4. Good. So I'm going to come and down here and I'm going to start with 0. Go to negative 4. What type of circle at negative 4? Closed. Shade which way?
Right.
To the right. Okay. Next one. What do you do over here? Add 3. So I get y is less than or equal to?
-1.
-1. So then I'm going to draw a new line. At -1, what type of circle? Closed. And which way am I going to shade?
Left.
To the left. Now, our final answer is going to be the intersection of those 2 graphs. So I'm not quite done yet. So you can see that the first one we looked at, that's the easier of the 2. So here's 0. What am I going to do? So in a nutshell, tell me where I start. Closed circle at -1. Back there?
Closed circle at -4.
Closed circle on -4. What do we do?
Shade in between.
Shade in between. There you go. So that's your solution. So basically what that means is that everything in the middle, okay, satisfies those 2 inequalities. Alrighty, you try this one for me. Quick, quick. Shouldn't take us very long. Yep. Well, I don't know. It doesn't matter because we're going to do it as a group anyway. I'm going to start with somebody to do the solution, and then we'll graph. Kelly, you got it done? Okay, could you do just solve the inequality? So, when all is said and done, okay, good. All right. Jeff, start by graphing. Do one part of the graph, kind of like what we did before. So if you want to do one. Okay, next part of the graph. Kelsey. Okay, finish it out, if you would. Now, real quick, okay? Everything looks great. There's one little change that I would make. Okay, the change I'm gonna make is to do this. Okay? Reason being, if you notice, there is no equal to sign right here. So since there's no equal to sign, we're gonna use an open circle. Okay, so that's just one thing to keep in mind. So that is intersections. Okay, now we're going to talk about unions. Okay, they use the word or. Now the word or doesn't mean both things have to occur. Example, if I said you're wearing blue jeans or a black sweatshirt, would this be true? What Kylie's wearing?
Yes.
Yeah, because she's wearing blue jeans, not a black sweatshirt, but it's true. Would this be true, what Aaron's wearing?
Yes.
Yeah, he's wearing both. What about AG over here? Yep, what about Maddie?
Yes.
No.
Oh, yes.
Yeah, she's got a black sweatshirt. Okay, so or just means it has to be in one. So we're gonna go ahead and graph this. Let's start with x is greater than 2. I'm gonna start here with 0. 2. So x is less than 2. Open circle at 2, shade which way? Or x is greater than 2. I said less than, didn't I? I said that wrong. Let's look at our next one. Okay, our next one is x is less than or equal to -1. What can you tell me there?
You have to have a closed circle and go.
A closed circle on -1 and shade which way? Shade to the left. So now, remember what I said about or. In order for it to be true, it just has to be in 1. So if I'm going to graph x is greater than 2 or x is less than or equal to -1, is this left arrow shaded in at least 1? Yep, so it's going to be shaded here. Am I still shaded in at least 1?
Yep.
Yeah, because I'm shaded blue. Am I still shaded in at least 1?
Yep.
Am I still shaded in at least 1?
No.
No, I'm not shaded here. What about here?
No.
What about here?
Yes.
No.
No.
Well, I'm going to have an open circle, right?
Yeah.
Am I shaded?
Yeah.
Okay, so with or, when you combine them, you're just looking that they're shaded in one or the other. Now I want you to think about things real quick. What happens if this bottom one was actually like this?
Then
That's an
What
and.
can you tell me about your solution? Just think about it real quick. I'm going to give you about 10 seconds. I want you to think, if this was the word or, what would your solution be? Ideas?
it would just be one line to the left.
It'd be what?
It would just be less than.
Yeah.
You don't shade the part that's where there's 2 lines or something.
Let's think about that.
Just don't
So remember what I said. What would this solution be? No ideas?
Would it be the whole thing?
Ah. Let's think about that. Am I shaded in one or the other?
Yeah.
What about here? Am I still shaded in one or the other?
Yeah.
Yeah, because I'm shaded right here. So this would be an instance of which you get the whole number line, and you can do that. That's
Right.
fine. Okay, all it has to do is be shaded in one or the other, or it could be shaded in both. All right, so let's go ahead and look at a solution here. Solve each inequality, then graph the solution set. So what's the very first thing I need to do here?
Subtract
-7. Now the thing with or, it doesn't have a fancy way to solve it like the and ones did. Okay, it's going to take a little more work. So -2m is less than or equal to what?
13.
No.
How about
6.
6? Now, what are you
Oh,
going to divide
6.
by? -2, however,
And then you flip the sign.
you have to flip the signs if you divide by the negative. -3. Or, let's solve this one. What do you have to do here?
Subtract 12.
Subtract 12. So I end up getting 5m to be greater than 25. Divide by 5. I get m to be
Greater than 5.
greater than 5. So now I need to think about that. M is greater than or equal to -3, or m is greater than 5. So let's start. Oops. Let's go ahead and start. I've got 1, 2, 3. So first one, m is greater than or equal to -3. So I'm going to go ahead and start with a 0. Here's -3. What type of circle on -3?
Close.
Close. Which way do I shade?
Right.
Okay. Let's look at the next one. We'll do orange. So here's 0. Here's 5. What type of circle on 5?
Open.
Which way do I shade?
Right.
Now let's go ahead and do our final solution. We'll do those in red. Okay, so I start here at 0. Am I shaded in my left arrow?
No.
What about, where do I start?
-3.
-3. So -3 starts with an open, or with a closed circle. Am I still shaded?
Yep.
Still shaded?
Yep.
Still shaded?
Yep.
Still shaded?
Yep.
Yep. Still shaded? So this is one in which, okay, it looks a little different than the ones we looked at, but it still works. All right, one more I want you to try. There you go. You try that one for me. X is less than or equal to 9, or 2 plus 4x is less than 10. Okay, so first of all, we end up having x is less than or equal to 9, or x is what?
Less than 2.
Less than 2. So if I were to graph this on a number line, here's 0. Somebody tell me what it's going to look like?
Closed circle.
Closed circle on 9.
Shaded to the left.
And I'm going to shade to the left. Okay, because what ends up happening is, and this is something you could do on your homework if you didn't necessarily want to draw 3 lines, you could say x is less than or equal to 9 looks like this. Okay, x is less than 2 is going to look like this. So obviously if you extend them and you combine them, that's what you're going to get. So you could do 2 little lines like that instead of having to actually draw out 3 big lines. Hey, let's go ahead and turn in your book to pages 308 and 309, and let's look at this. So pages 308 and 309, your first instructions. Okay. The number 6, solve each compound inequality, then graph the solution set. Okay, solve each compound inequality, then graph the solution set, and then you have 18 through 27. I need you to go ahead and look right now at number 18. Number 18, if you notice, says write a compound inequality for each graph. So we're actually going to look at number 18 and number 21. So on number 18, am I going to use an and, or am I going to use an or?
And.
An and. Now this is the easy way to do this. What are my endpoints?
-1 and 4.
-1 and 4. What do you know about x when you're writing an and statement?
It's greater than -1.
It's going to be in the middle. Let's write that one in the middle. Remember, -1 and 4 are my boundary points. Now the question is, which way do the inequalities point? Do they point to the left or to the right?
To go right.
The left.
Depends which one.
Yeah.
They always go to the left if you're going to use an and statement here. Now, am I going to use an equal to sign on -1? Yes or no?
Yes.
Yes.
Why?
Cause it's a closed
Because it's
circle.
closed. What about at 4?
Yep.
Equal to
Yep.
side? It's closed. That's all you do. Boundary points, put X in the middle, inequalities to the left. Then make sure you use the correct ones. Let's look at 21. Is 21 an and or an or? It's an or. So I'm gonna write two separate inequalities. So let's start with the first one. The first one's gonna refer to the one that goes to the left. So X is it gonna be greater than or less than?
It's less than.
Less than, what value?
Negative 4.
-4. Or, now I'm gonna do my one for the right point. X is what? Greater than?
-3.
-3. There you go, that's it. So that's what you're gonna have to do on the last few. I just wanted to make sure that you understood those before I let you loose. Okay, so that assignment due tomorrow. And as I said, I'll have your schedule in the next day or two as to what we're gonna do the rest of the semester. Okay?